So now we're gonna solve the fifth question from day 6, that is the linked list cycle 2. So what is given in the question? We are given the head of the linked list and we have to return the node where the cycle begins. If there is no cycle, we will return null, and if there is a cycle in the linked list, if there is some node in the list that can reach again by continuously following the next pointer internally, position is used to denote the index of the node that tail's next pointer is connected to. So there is so much of theory written. So basically what we have to do, we are given a linked list. If there is cycle present in the linked list, we have to return the node where the cycle begins. So here the cycle begins at node second. Here the cycle begins at node first. Here there is no cycle, so we'll return no cycle. So this is the question. We have to just first we have to find if there exists a cycle in the linked list, and if there exists a cycle in the linked list, and we have to return the node where the cycle starts, where the cycle begins. So how are we gonna approach this question? Okay, so this is our given linked list. So what we have to do in this question, we have to first detect if there is cycle or not. We have to find there is cycle or not. If there is a cycle, we have to find the node at which the cycle begins. So we have to find the node at which cycle begins. So in this question, in the given test case, sample test case, we have a cycle. As we can see, we have a cycle, and our cycle begins at node second. So how will we going to find? First, we will detect the cycle. What we'll do, we'll use two pointers, slow and fast pointer, and slow will move one step, okay, and fast move two steps, okay. Slow moves one step and fast move two steps. So what we're gonna do, we're gonna make at the starting, the slow and the fast pointer will be pointing to the head of the linked list, okay, and we're gonna make the condition of our loop such that until our fast pointer would be pointing to the last node in the linked list. Last node in the linked list would be pointing to null. So it is the condition when there is no cycle in the linked list. Because if the fast pointer has reached the end of the linked list, that is where the fast of next equals to null. That is the condition when the fast pointer will reach the end of the linked list. So that means there is no cycle present in the linked list. So if no cycle present, we'll say no, we'll return false, we'll return or we'll return null, because there is no cycle in the linked list. Okay, so what we'll do, we'll move fast two steps. So fast will pointing to this pointer, and slow one step. At every iteration we'll do the same procedure until we find that slow and fast will be pointing to the same node, and this is the confirmation that if the slow and the fast pointer will meet, then there would definitely this be then there would be definitely a cycle. Okay, so at the next iteration, slow and fast pointer will be pointing to this position. At the next iteration, slow will be pointing to this, and the fast will be pointing to this first jump and the second jump. So fast will be pointing to this. Okay, so At the next iteration, slow will move one step, fast will move two steps. Okay, so now slow will be at this node, slow will be at this node, and the fast it moves two step. So one to this, second to this. So our fast and the slow pointer become equal. So it is the confirmation that there is cycle in the linked list. Now what we gonna do? We have found the cycle. Our first task is complete. If we have the cycle in the linked list, what we have to do? We have to find the node at which the cycle begins. So how will we gonna approach it? We again use the slow and the fast pointer. Now we'll make one of the pointer points to the head of the linked list and the other pointers remain the same position at which the slow and the fast pointer meets. So let's suppose fast remains at this position only and slow will be pointing to the head. Now our condition is such that fast will be moving one step and slow would be moving one step. So the both the slow and the fast pointer would be moving one step until they both will be pointing to the same node. In that node will be the beginning of the cycle. That is this. So what we'll do? We'll move slow by one step and fast by one step. So moving fast by one step, so fast will be pointing to us. So our slow and the fast pointers are pointing to the same node. So this node, we can say this node is the beginning of the cycle. Okay, so this node is the beginning of the cycle. So we can return any of the pointer will return. So what are the steps? What is the steps? First, we have to detect the cycle using the fast and the slow pointer, in which the slow pointer move one step and fast pointer move two step. In the next condition, if we have detected the cycle, we have found if we have detected the cycle, what we have to find, we can use we'll make any of the pointer points to the head and moves the slow and the fast pointer by one step until the slow and the fast pointer would be pointing to the same and will return pointer to that any of the okay. If we do not detect a cycle, we'll return null. This is the simple algorithm to solve the question. Now we'll discuss the code. Okay. So now we're going to discuss the code for the discussed approach. So this is the function will detect cycle that returns the pointer to the node at which the cycle begins. So we have received a parameter that is the head of the linked list. Okay. If there is no element in the linked list, we return null. Otherwise, what we want to do, we want to maintain two pointers. Initially, both are pointing to the head of the linked list. We have maintained a flag. So what is the use of this flag? The use of this flag is to detect whether there is a cycle in the linked list or not. Okay. So we are using a while loop. In the while loop, we have maintained a condition until our fast pointer will be pointing to the end of the linked list or to the end node. We want to move this. Okay. And our flag value initially is set to and it will change to true if the slow pointer and the fast pointer become equal. Okay, we have moved the slow pointer by one step, fast pointer by two step, and if the slow pointer and the fast pointer become equals, we're going to return true and break through. Okay, and if the flag remains as it is, that is, we have reached the loop end and the flag remains as it is. That means there is no cycle in the linked list. Flag remains false. false conjugation, that is true, will return. Okay, will return. Otherwise, we make any of the pointer points to the head of the linked list and moves the slow and the fast pointer one step, each pointer by one step until the slow and the fast pointer become. If they become equal, that is the starting of the cycle. So we'll return the pointer pointing to the node that is the starting of the cycle. So this is the code for the approach that we have discussed. If you have any doubt, please feel free to ask. Okay, or put the description in the chat. Okay.